Why should we use hydrogen energy?
Hydrogen energy is one of the cleanest form of energy as it does not have any carbon in it when compared to fossil fuel. The byproduct of using hydrogen is only water.
Can we use the same water again and again to make more hydrogen?
Yes, of course you can use the same water to produce more hydrogen, but it will require new electricity every time to convert into hydrogen.
Where does the hydrogen gas come from?
Hydrogen gas is not naturally available in our planet Earth. Hydrogen gas is produced from primary energy sources such as natural gas or via electrolysis of water using electricity from wind turbines and solar energy.
I have heard about the different colors of hydrogen. What is green hydrogen and what is grey or blue hydrogen?
If hydrogen is produced from water using electricity from renewable energy sources such as solar energy, then there is no CO2 emission. Then this is called green hydrogen. But when hydrogen comes from fossil natural gas, CO2 is produced as a byproduct. And if this CO2 is escaped to the atmosphere, it is termed as grey or brown hydrogen. Most of this hydrogen available today in the world is grey or brown hydrogen. When this CO2 is captured and prevented from being escaped to the atmosphere, then this hydrogen will be termed as blue hydrogen.
Okay then, we need more green hydrogen to prevent CO2 emissions and to meet our net zero goals.
Yes, of course we need more green hydrogen by looking at the future.
What are the usages of hydrogen gas?
Hydrogen has many usages. Hydrogen gas is used as a fuel in vehicles such as buses, trucks, trains, boats, and aeroplanes. Hydrogen is used in fuel cells to produce electricity and heat in residential and commercial sectors. Also, new gas boilers and gas cookers are coming to the market to use hydrogen gas.
Well, it sounds like hydrogen can be used everywhere to decarbonize the transport, electricity, and heating sector.
Yes, I agree with you.
Is hydrogen an expensive fuel?
Well, the price of hydrogen is contextual. It has to be compared in specific situations. Let me explain. An electrolyzer consumes about 60 kWh electricity to make 1 kg hydrogen. Self-generated electricity from large-scale solar farms costs about 2 pence a kilowatt-hour or even less. So the electricity cost to make 1 kg hydrogen is 1.2 pound. Now, this 1 kg hydrogen has the same energy as in 3.7 liter of diesel, which costs about 5 pound in the UK at present. So the savings in hydrogen is the difference of 5 pound to 1.2 pound, which is 3.8 pound per kilogram of hydrogen. That's not all. For every 1 kilogram hydrogen produced, 7.8 kilogram oxygen is also produced as a free byproduct in an electrolysis process. Oxygen has high market value too. So, when the market price of hydrogen and oxygen is combined, it is way more valuable than the cost of the input electricity to make them. So, it is not only greener and sustainable, it can be cheaper when the rising prices of petrol and diesel is taken into account. By the way, The current price of hydrogen on the market is about £130 a kilogram, and oxygen is equally expensive, as both hydrogen and oxygen has extensive usage as chemicals.
Wow, I didn't realize about the significant business opportunities in the near future to use green hydrogen to displace petrol and diesel. Well, you have talked about the major potentials of green hydrogen to displace fossil fuels, but how safe is hydrogen? People fear about the safety of hydrogen.
This is a very good question indeed. Let me compare hydrogen fuel against diesel, propane, and natural gas. Generally speaking, hydrogen has much less energy than petrol, diesel, or natural gas per unit volume. Hydrogen is generally stored as a compressed gas in cylinders and in some cases as liquid hydrogen under cold temperature and high pressure. So for safety analysis, hydrogen should be compared on volumetric basis such as kilowatt hour per liter in hydrogen. Interestingly, diesel has 10 times more energy than hydrogen even at 350 bar pressure. Even 1 liter liquid hydrogen has only 1/4 energy than that of 1 liter diesel. On the basis of energy density, hydrogen can be considered safer than diesel. Natural gas, what we use at home to cook our meals and to run our gas boilers, has 3.5 times more energy than hydrogen at any pressure and volume. So again, hydrogen can be considered safer than natural gas on the volumetric energy density basis. Let's look at differently. The flammability range for hydrogen is 4% to 75% by volume in air, but for natural gas, it is 5% to 15% by volume in air, which means natural gas reaches its higher explosion limit well ahead of hydrogen gas. The LPG, liquid petroleum gas, such as propane, has the flammability range from 2.15% to 9.6%, which means a small leak of LPG reaches to its higher explosion limit rapidly. And LPG, being heavier than air, settles at the bottom of the floor and does not get dispersed easily. On the other hand, hydrogen has a very small molecule with a significantly greater diffusion coefficient than other gases, which means in a ventilated place, hydrogen will disperse 5 times faster than LPG. Thus, it is difficult for hydrogen to reach its higher explosion limit, as this requires 75% concentration in air as long as there is a suitable amount of ventilation. The flame temperature of hydrogen is slightly higher than natural gas, but it is still comparable. Considering all these factors, hydrogen is another fuel that can be produced from water, and the prescribed handling procedures for hydrogen must be followed.
Thank you for answering my questions about hydrogen and clearly explaining the benefits of using hydrogen.
Thanks for asking me those interesting questions.